Yeah, hi, good evening, everyone. So today is the last session for this competitive programming course, and we will cover both week 11 and week 12 programming problems. And also, if you have any query, you can also ask during the session. Okay. Uh, okay, Sarnath.
Yes, sir.
Yeah. Okay.
Yeah,
Please
let
start.
me share my screen. So, yeah. So, is the screen visible for everyone? Can someone?
Yes.
Yeah. Right. So, yeah, I got the chat box. Okay, anyways. So, let's go through the week 11 question first. So, as Dasara is approaching, you're so excited as there will be a lot of sweets and savories cooked in your house. But you have some rules which should be followed to eat the sweets. Else, you cannot eat them. So, this is the constraint. So, we will see what are the constraints for this question. So, what they gave is imagine all the sweets are arranged in a line and the type of the ith sweet from the left is AI. So basically what it says is we have been arranged, sweets in a line, and ith sweet is the type which is named AI. Here we'll denote them with the numbers. So what they say is you can do the following operations any number of times. So select I and J such that 0 less than or equal to I, less than J, less than N, and AI equal to AJ. Suppose we find two similar sweets, and what can we do is remove AI to AI, comma AI plus 1 to AJ from the array. So basically, if we have remove them and also the between sweets which we have literally. So let me explain you with an example. Suppose here we have 1, 2, 2, this type 1, type 2, then type 3, type 3. So I have two sweets, say type 2, right? So I can remove these both. And again, I can remove type 3 all. So now else what can I do is suppose I have like say 1, 2, 1, 2. Here I have a type 2 sweet and a type 2 sweet. So I can remove from here index 1 to index, the last index, which is index 3 in this case. So that's what we have been, the explanation. So the input is very simple. Like we have t test cases and each, the first line contains the integer n, which denotes the number of sweets. And the second line contains the types of sweets. And we have to get the maximum number of sweets that can be eaten. So in some sense, we could intuitively find that as we have these conditions, basically we cannot opt any greedy algorithm because that might result in any wrong answer. So what we will do is we will go through with the dynamic programming approach. So if you could see in the first example, we chose I equals 1 and j equals 2. So I equals 1 is this and j equals 2 is this. All are zero based indexing. And in the first operation, what will happen is if we remove 2, 2, we'll be left with 1, 3, 3. That's what we have been given here. And then if we choose I equals 1 and j equals 2. So basically after it becomes 1, 3, 3. So I equals 1, j equals 2. Again, we can remove this 3, 3 and we'll be left with just a equals 1 and we cannot remove anything because we don't have it. We need at least 2 sweets to get removed. So at last, what we are doing is we are eating 4 sweets in total. But in the second case, what will happen is we'll choose I equals 1 and I equal to 0, j equals 2. So we can choose this 1, 1 and we'll eat 1 to 1 and we'll be just left with 2. Now we cannot do anything else. So we'll eat 3 sweets in total. So I believe you have understood the question fully. So let's look at the solution for this. So yes, so this is a very simple Pythonic solution which uses a dynamic programming. So the point is first we are getting the t equal to int of input of which like says I have to get the number of test cases, and in each line we have been getting the number of say sweets, and in this array we are storing the indices of the types of sweets. Now what we do is we create a simple DP array which is of like say TP table which is like 0. So we are using our dynamic programming instead of memorization as it's very intuitive. So and we have this S equal S dictionary to store the values. So values of the minimum, the maximum sweets. So for each index, we'll be storing the maximum number of sweets in this. So now what we'll do is we'll look for I in range of 1 comma len of a plus 1. So len of a plus 1 is like why we can use this for I in range of len of a, but for indexing basically we are using for I in range of 1 comma len of a plus 1. So what we are doing is if a of I minus 1 is not in S, that is if suppose a type is not in the S, I'll append it to the DP and then I'll actually get the value in some sense. So I'll have this as S of A of I minus 1 equal to DP of I minus 1. Till now, this is my maximum switch which have been possible. So that is what I store in this S dictionary. Else, if suppose I found some A of I minus 1, that is some sweet in my already in my table, then what I'll do is I'll do the minimum. Basically, what is the minimum? Basically, here it will be min of dp of I minus 1. That is the previous one, current number of sweets. So this is what our agenda is. And then we'll append it to the, we'll add it to the S dictionary here. So that is what we'll be doing here. So why we are doing here min? That's because we have to store the minimum, say the value of the sweets, so that we'll get them. We have to remove the minimum elements so that we'll be left with maximum, say sweets. So that's what the intuition is here, some sense. And at last we'll be displaying the total number of sweets minus the whatever we removed. So if we remove the minimum sweets, there'll be maximum sweets possible, array, and we'll get the number. If I want, I'll repeat it again. So the point is, first we are getting the test cases and we are getting the inputs. We are forming a dynamic DP table first, which is 0 at the first, literally, and we have an empty dictionary S here. So where we'll be storing the minimum values of the type, each type. So now we look for I in range of 1 comma len of a plus 1. If suppose my type is not in S, then I'll add it to my S. Else what I'll find is I'll minimum of the previous one or the current S of A minus 1. So I'll find the minimum here. Why I'm finding the minimum? So if I remove the minimum number of sweets, I'll be left with, and then at last we are printing whichever is left. So is there any doubts? So I believe, suppose any doubts, if people can ask. So, okay. So I believe then if there are no doubts, then let me move towards the week 12 problem statement. So, okay. So the week 12 problem statement goes like this. So Jeremy is an undergrad student studying at a university. So there are n working days in the college, and each of these days, Jeremy might have some classes at the university. There are m working hours during each day, and each lesson at the university lasts exactly 1 hour. So this is what it says. So basically, I have some n working days, and there are m working hours in each day, and each class only lasts for 1 hour. If someday Janani's first lesson is during ith hour and the last lesson is during the jth hour, then she spends j minus I plus 1 hours in the university during the day. If there are no lessons during some days, then Janani stays at the home and therefore spends 0 hours at the university. So the point is still the start of the lecture, maybe from the first class till the end, basically she sits. That is what it says. Suppose I have, if I have I only have a second period and the fifth period, basically the second period to fifth period, or only the second period and fifth period. So I'll only sit for 5 minus 2 plus 1 hours. That is maybe 4 hours, right? So that's what the question says. So Janani doesn't like to spend a lot of time in the university, so she has decided to skip some lessons. She cannot skip more than k lessons during the week. After deciding which lessons she should skip and which she should attend, every day Janani will enter the university right before the start of the first lesson. She does not skip and leave it after the end of the last lesson. So she doesn't want to sit the whole day and waste her time. So what she will do is she'll start from the first class, and then from her first class, and she'll only sit till her end class. That's what she does. She doesn't want to sit all the say maybe m working hours maybe, but she want to somehow sit only the subset of M working hours. So if Janani skips all lessons during some day, she doesn't go to the university at all. That we have already gave that she spends only 0 hours at the university. So now what is the question is, given this N comma M comma K and Janani's timetable, can you determine the minimum number of hours she has spent in the university? So again, this is like trying to minimize some constraints. So we can think of some greedy algorithm, but we could easily prove that any greedy algorithm will not work for this question. So we are actually enumerating all the possibilities with the help of with the efficient way of dynamic programming. So let's see the input. The first line contains 3 integers n comma m comma k, which is like n is the number of say working days, m is the number of working hours in each day, and k is the total number of classes she should attend compulsory. The number of working days of the university in the week, that is what we have said. So then n lines follow ith line containing a binary string of m characters. If jth character in the ith line is 1, then Janani has a lesson on ith day during jth hour. So what does it mean is, so I have this binary string, and if suppose it says 1, then I have basically a class. I mean, not me, Janani has a class. So else she don't have. So in this case, maybe say she has a second period and the last period, maybe second here, third, fourth, fifth period. So what I previously said is like she should come exactly the second hour, and then she has to stay all the way. So she has to spend at least 4 hours here. And here again, if suppose she has to attend all the classes, but here she should only attend one class each day. So she can spend only 1 hour in the first day and 1 hour in the second day. So maybe that's how we can, but she have to sit all along. So that's what she should not skip more than K classes. So she cannot skip more than 1 class. That is what K means. It's like not saying she should attend these classes, but she cannot skip more than 1 class. So maybe here basically she can skip only 1 class, and here she can skip only 1 class means, so we have to like say 1 to 1. So she have to sit here to here. So 4 hours plus 1 hour, which is 5 hours. That's what the answer is. So easily we could find that this is like a dynamic, but here she should not skip any class. So she should sit 4 plus 4 literally. So 8 hours she should spend her time. So let's try to get the solution. So hopefully the question is clear. If not, if suppose, yeah. So what we are going to do here is we are going to construct something called min subarray. So what does this min subarray means is, so for each class, I'll find the minimum, say if suppose, say I have a day and I have the at most classes K, what I'll do is I'll somehow find the at most K classes should be cut. So this is what we are doing. So what I am doing is, first I am checking if not, if suppose there is a day, the day is just a list. So if not day, return like I just written everything basically. If suppose there is no day, then this is the base case. Then what I do is I find the length of the day, and this like best is basically the maximum. I am taking the best is an array which has basically infinite everywhere, where n plus 1 entries are infinite. So now best of 0 is 0, best of 1 is 1. So now what I do is, for size in range of 2 comma n comma, imagine the size as j in some sense. So that's what here I mean. So for size in range of 2 comma n plus 1, for I in range of n plus 1 minus size. So what does this mean? Till the last before, I am just checking best of size equal to min of best of size comma day of I plus size minus 1. That is, this is I plus j minus 1. So I have to generally have to set at least I plus j minus 1 hours, right? So that's what I'm here doing. So day of I plus size minus 1 minus day of I plus 1. So this is the extra term which carries forward the which takes care of the overflow of the array. So this is what now I have updated my best. This is literally the dynamic DP array you can think of. So now what I'm doing is, now I need the output. This is only the best of size. Now I need the output. Now it should also follow the other constraint, where we should attend at least the K classes, right? So that we have to follow. That we did not check till here. So what I'll do is, for I in range of K plus 1, if n minus I greater than 0, then output of I equal to best of n minus I. So till only I have to at least attend the K classes. So that's what the constraint is. So that I have appended to the output, and I'll return the output. So hopefully you understand what is min sub array. So min sub array, what it stores is how many classes I can basically store in the how many classes I can attend if suppose I have to at least attend k classes. So now what I do is I take the input, basically n comma m comma k, where n is the number of days in the week, m is the number of hours I should attend, k is the minimum number of classes I have to attend. So now I like have this day equals to I. This is basically I've just made into two values, as like if value equals 1, it's like I comma value in enumerate of like I've taken the input, and best equal to min sub array of a comma k. Literally. So I've got the best array now. Now what I'm doing is for I in range of like for this underscore in range of n minus 1, day equals to, so now first now it is for the first iteration. This is only for the I get 0 and 1. But now I have to do for the other cases too, literally. So what I'm doing is day equals to, this for only one day, in some sense you can think of. Now I have to do for others days too. So day equals to, I'm doing the same thing. New day best equals to min sub f, and I'm finding the minimum basically by doing the same thing, literally. For I in range of k plus 1, for j in range of I plus 1, new best of I equals to min of, this is the same thing which I've done here, the same optimization. And then I've updated my best. Each and every time I'll be updating my minimum subarray. So that's what I'm doing. And at last I'll print the best of k. That is the last value, literally, which will store me the minimum number of minimum number of hours I have to spend in the class. So again, suppose. So let me again repeat my answer if suppose if it is confusing. I believe this should be a little bit, yeah. So what I have done is first I'm having a min subarray where basically I'm the minimum number of classes I have to attend for a single day. So what I store is I have a DP array best, and I have initialized best of 0 equal to 0 and best of 1 equal to 1. That is the base case. And now for size in range of 2 comma n plus 1, that is like for the other classes, I update my best, literally. That is my DP array. And I now have to add the constraint that I have to attend only k classes. So I have initialized an array output equals to, and then I have give this condition, like if n minus 1 greater than 0, output of I equals to best of n minus I. And then at last I return the output. This is my minimum subarray for a single day, comma k class. Now I'm asking, now I do for a single day, then I use a loop to do for the other days too. And then I update my best each and every time I get it. So best equals new best. And then at last I print my best of last, the best of k, which is going to give me the final value of how many minimum classes I have to attend, so that it will be possible for her to skip the classes. So hopefully, is it any doubts? No? Suppose no doubts, then to have any general questions, because I believe this week everyone will have their NPTEL exam. So try to practice, and all the best for everyone.
Yeah, okay.
Hello?
Thanks, Sarnath. Yeah, Pushpin. Yeah, am I audible?
Yes.
Hello?
Yes, yes.
Yeah, Pushpin, go ahead.
Yes. Anyone? Yeah. Yeah. Can anyone hear me? I mean,
yeah, Sarnath, you are
Atul sir
audible.
is talking.
Sarnath?
Yes.
I think, yeah, you can stop. Now, Pushpin will start.
Am I audible?
Yes, you are audible.
Yes.
I think Sarnath is not able to hear us.
There is a question on the chat. If you would be able to answer.
Okay, yeah. Sir, what will be the exam pattern? Also, please discuss questions 7 to 10 of week.
Hello.
Okay, Deva. So after completion of this programming question, we will discuss about this exam pattern and.
Can you hear me, right? I mean, was it audible?
Yeah, Sarnath, you are audible.
Yeah, I mean, was the discussion also was and all? Should I repeat?
Yes. Yeah.
I mean,
you are audible, but I think you are not able to hear us.
Yeah, now I can hear you now. Yeah.
Okay. Now you can stop. Now Pushpin can come.
Yeah, I stopped sharing, right? I mean,
yeah, your screen is stopped.
Yeah. Thank you. All the best, everyone.
Okay.
Okay, so week 11 programming assignment 2 is the statement goes something like Shrek has started on a journey to rescue the princess from evil monster that has trapped her in a dungeon. The road is long and he needs to plan his journey so that he makes the minimum stops in the villages along the way. At each village he chooses to stop, he gathers resources that would help him in his journey to reach the next village. Help Shek find out the minimum number of villages he will stop at for replenishing the resources to make his journey to the dungeon possible. The constraints are like there would be the number of villages between 2 and 2000, the number of the number of resources that can be gathered on a specific on a at a village is between 1 and 1000. So the input is like same, the number of you get the number of villages. The next line gives you the number of resources that can be collected at each resource at each village to make the subsequent journey. So is to go through this example that on the first village, he can choose to collect either one resource or two resources. Uh, Resources which would help him skip this first town. If he chooses to select two uh, resources that would help him skip two villages, he would end up at the third village. So what you need to figure out is the minimum number of villages he can skip before reaching his destination. So here's the explanations. Shrek calculates resources at the first villages, reaches the third village, which is this, without stopping at the second village. At the third village, he collects resources to reach the next village. At the fourth village, he collects resources to reach the dungeon, which is located at the seventh position. So first, second, third. So this is how it is, meaning this, I think the problem statement should suffice. Uh, Hence the number of, so he collects the resources from here for skipping the to reaching the second village, which is 1 and 2. At second, he can choose again collect resources to reach or either this village or this village. But if he chooses to reach this village, he can collect all the resources which would help him reach the end of the destination, meaning at the destination itself. Uh, I suppose the problem statement is pretty straightforward. Going to the solution, it's basically we are going to solve it by a dynamic problem DP. What you create is we create a DP array, and we step for the last step, meaning which is the last destination, you set it to 0, and you what we are doing here is we are looping from the end of the array to the 0th index of the array. Here what we are doing is, given the number of steps he can take, we figure out what would be the minimum if he chooses the anywhere between the first and the nth step itself. So if I take this example, he can choose to reach this village or this village or this village. Which of these would give him the minimum number of jumps is what we're trying to figure out. Hence we iterate over the number of steps at that particular village, figure out if we have reached the end of the village at the destination itself or at the end of the array. Then the number of steps is 1 itself. If not, we add to whatever is considering the current village and the next step plus 1. So at and after this we update the value minimum steps from that position for that village. And at the end of this entire loop, we return the number of steps that would have been taken at the starting from the 0th position, which is this this location. And that's pretty much it. Any questions? So week 12 is also it's little convoluted in terms of how the problem is structured, but the intent is very easy, given by the hint as well. Human mind has been a source of awe for its creativity. Lying is also a creative process, but lying is often grounded in reality. You have stumbled upon the code to unlock the secrets of the mind. However, the code is distorted because the individual who gave you the code wants to fail in that pursuit. Later, you find another code claiming to be authentic for opening that secret. And this code is entirely different from the one you procured, at least at first glance. Now, with the knowledge that lying is grounded in reality, you devise a method to figure out the code based on this assumption, which assumption that the code itself, even though parts of it is all gibberish and probably wrong, some of it has some truth to it. So you figure out which are the parts which are common within those code, and you figure out what you need to output, what's the length of, at least what is the length of the code itself. So here you, with the first line, the length of the code itself is between, for each of the codes is between 1 and 2000. The first line contains a sequence of characters representing the first code. The second line contains a sequence of characters representing the second code. So here, these are the codes for the first sequence and the second sequence. And if you if you notice that the possible code could be either CA, CB, or CD. So the length of all the codes is 2. That's pretty much it. Now this is a longest common sequence problem. So going to the solution, it's pretty simple. You create a 2-dimensional array. You loop through from bottom up. You for each index you build whether so your 0th index would be all zeros. Your 1 j for j varying between 1 to n would be all zeros, and same with I comma 0. And you figure out if the sequence between the first sequence and the second sequence index is equal, you increment the value from its diagonal value. And if that is not the case, you take the max of the topmost or the leftmost index, and that's pretty much it. You figure out the index, return the last value of that index, and that should be give you the length of the code, at least, which are common across both sequences. So yeah, that's pretty much it. Any questions? Okay. So yeah, I'll stop.
Yeah, okay. Yeah, Pushpin, thanks. Okay, so Deva asked some question. Yeah, Deva, can you open your mic? And so first thing you are asking that about the exam pattern.
Yes, sir.
Yeah, so regarding the exam pattern, so questions will be similar type of your assignments like MCQ, MSQ, and numerical input. 3 types questions will be there. Okay, so so on TCS Center you cannot write the code like this programming assignments. So only MSQ, MCQ, and numerical input type questions will be there. And regarding the questions type, so yeah, some part of the questions paper will be similar to your assignments questions. Okay. So just
And
revisit.
how
Yeah,
many questions?
so yeah, questions will be distributed based on the 3 hours. Duration of the exam is 3 hours, correct?
Yes, sir.
Yeah. So that questions you can assume like 30, 25 to 30. Okay.
Yes, sir.
So just revisit your all assignments, graded assignments, and also practice assignment, or also just revisit these problems. Okay. And so
Yes.
some part of the questions will be similar to your assignments, and some part of the questions will be similar to your programming questions like this. So where the one problems will be given, and you have to identify the strategy steps, like the steps question will be asked. Okay, based
And
on any particular problem.
so there is a one question, longest increasing subsequence, which is done by the DP in this course,
Hmm.
and its time complexity is about O of n square, but it can be done in other way also, which gives O of n. So in exam, if we are asked the optimal time
No,
complexity,
how you can identify the solution in another way O of n?
so there is a method of telling it in O of n.
So which approach you are using? Do you know about that method?
Yeah, yes, sir. The striver has also Raj Vikramaditya. You may know him. Has a video on it.
Hmm.
So
Okay, so that's not a problem. If you have any better solution, so that you can use that. Okay. Otherwise, we are solving this problem using DP.
okay, sir. No,
Okay.
sir. If like a question is asked, what is the optimal time complexity for a code
Yes,
for a
yes,
question?
correct. Yeah, if
Then
anything,
give
if you
answer.
have any better solution complexity, then you can mark the answer accordingly.
Okay.
If this type of question asked. Okay.
Yes, sir.
I think you have also mentioned on the Discord regarding this ninth question. You
Yes, sir.
mentioned,
Yes.
or yeah, okay.
Many
So we
other
are
students have also mentioned.
so we are also considering this your post. Okay, this re-evaluation, like, so one question definitely we are re-evaluating, that we are the LCS questions, longest
Yes, sir.
some. Okay.
Third question.
Yeah, well, let me share my screen one second. Oh, let's see. I hope my screen is visible.
Yes, sir.
Uh, yeah, this one. Okay, so you are talking about this. So yeah, this third question definitely we are re-evaluating. We are, because here answer this one should not be there. Okay, in the
Yes, sir.
solution, this one should not be there. Actually, this is wrongly added. So we are re-evaluating this, and also another is, you are talking about this ninth question. This.
Yes, sir. It will mean diagonal iteration.
Huh. So why we cannot fill this matrix diagonally?
So it will not give answer. It will
Why
be
it will not
not
give? No, suppose I am just considering this as a output matrix. Okay,
yes,
and
sir.
here, so the option is given like this. First you can fill this row wise. Okay, then down like this.
Yes, sir.
Okay, so this is the one option. First option is given. Another option is like we can fill
Downwards.
column wise.
Yes,
Okay,
sir.
column wise, this type. Correct. So these two options are clear to you, but diagonal option one, why we cannot fill like this? We can fill this. So this is the first point where we are starting. Okay, then we can fill like this. This is the way to fill like this. So in that way we are moving to this corner.
So
So every time you can fill in that way. Suppose if you are filling this part, so after first, if you are filling this location, okay, so here a hurdle is there, so you cannot fill. Okay, but here
yes.
you can fill, and you can see this location to fill. So the rule is given here, you can move to right and you can move to down.
Down.
Correct. So you
Yes,
can
sir.
just check the previous location to fill this. Okay, from here you can check the upper location to fill it. Okay, now these two column will fill. You can fill these 2 0.
So
Okay, you can
according
see.
to top left to bottom right after 0011 should be filled.
No, we are just trying to say this diagonally, like we are filling in that way. So this is the direction of the filling. Okay, so first we will fill this, and second we will fill this type in that way.
But sir, it is definitely not clear that first 00, then 10, then 01.
Yeah, so because of that, we are also re-evaluating this question. So okay, we are giving the, so I think you have got some partial marks, no?
Yes,
If you
sir.
have marked
We thought that after 0011, then 2210, then 33, and then
so yeah, so
we will
that
move
part
upward.
we understand that. Maybe you confused about this part. So in this way, we are getting. So I'm just trying to reevaluate, and we will give full marks if you have selected first two.
Yes,
If
sir.
anyone have selected first two, we will give full marks. Or if anyone selected all the first three, then they will also get full marks.
Okay, sir. Thank you,
Okay.
sir.
Yeah, so this is just we are trying to re-evaluate in this manner. Okay, so let's see if this is possible on the portal. This type of re-evaluation is the possible on the portal. We have to check this. Maybe so you will get marks, full marks for first two option also. Okay.
Maybe there will be hardly any student who has selected all three options.
This may be the confusion, but this is not the true. So all have marked the wrong answer for this question. Similar type of the previous problem, like this LCS problem. Okay, so this LCS problem, this is LC. Oh, sorry, not this. Yeah, this one. Yeah, this LCS problem and LCW problem. So all this matrix we can fill either column wise, row wise, and same diagonally. So diagonally, we are just trying to say here uh, diagonal row wise. We can see that like this. So this table we can also fill. First we will fill here, then we will fill this three column, then this like. Okay, in that way we can fill this complete matrix, and finally we will get the solution here.
Okay, sir. So if in exam, if it comes like this, then diagonal will mean like this.
Yes.
Okay, sir.
Okay, so we just mentioned three orders: top to down, and left to right, and one diagonally like this.
Yeah. So
In
actually,
that
diagonal one
question.
confused because after 00 we thought 11 will come, then 22 will be evaluated.
So yeah, that things I also think about that. Maybe confused how you will select the columns to fill. Okay, so no problem. We are just re-evaluating these two questions in this week.
Yes, sir.
Okay. So any other doubt?
Also, I was a bit confused about the statement of that question only, like the how to. So
This one?
from moving one step right or one step bottom in the hurdle question only,
Mm-hmm.
uh, it is one. It will take the cost of one.
So but we can. So you're talking about which question now?
This question only, sir.
Ninth?
If we are moving from 00 to 01 and there is no hurdle in between, then it will be one.
Yeah, cost will be one. Yeah, correct. But hurdle can jump on to the two location if hurdle is there. So suppose if you are at here, so hurdle can also jump at this location. So
And
this
it will
condition is
cost
also
you
given.
how much?
Cost will be one. Cost will be one. This jump
This will
will
be
also be the
also.
cost equal to one.
Okay, sir.
Okay. So in that way, these all constraints are required. So this question, so this is the initialization of the this table, and after that, in the next question, these are the induction to fill all the location. So how you can fill all the indexes. So here answer is for 0 because all the options are correct to fill this
Yes.
output table. Okay.
Yes, sir.
Yeah. So just first thing, just revise all the questions of the graded assignments. Also look the programming problems, and some question will be asked for the programming problem based, like your this programming assignments.
Yes, sir.
But questions will be asked in different way. Like this problem statement will be given, and strategy or steps or some solution types will be asked.
And so can we get PYQs of this course? Is there
PYQ
any
means
so previous year questions? of the exams
Uh,
that happened earlier years?
that we are not sure. NPTEL team is providing any previous year exam. So any sample paper you have received for
No,
exam?
sir. No,
Not
sir.
received.
Couldn't find on the Google also.
No, no. That actually these papers are not disclosed on the
Released.
any
Yes, sir.
public. Yeah.
Okay, sir.
Okay. So just practice on your assignment and also programming assignment.
Yes, sir. Thank you, sir.
Okay. Any other query? Okay, if there is no query, then we can wind up the session. Okay, so all the best, all of you. Sir, won't we have programming test? No, 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 Kirti, we don't have any programming exam for this course. We have only all this MCQ and this objective type of paper. Okay. No, no subjective. Yeah, MCQ, MSQ, and numerical input, similar to your this theory assignment, quiz assignments. Okay, similar type of questions will be there. There's no questions where you have to write the code programming assignment like this. Yes, syllabus is you know that till week 10 we have the content. So and there's no content in week 11 and 12. So DP questions we asked. Most of the questions are DP in week 11 and 12. So DP is the last topic of this. So yeah, you can assume that syllabus till week 10. Okay. Okay, let me open this link. Week assignment, week assignment. Okay, this is a practice assignment. Yeah, correct. So this type of question can be asked. So any problems is given and some input is given based on the strategy. Some question can be asked. Okay, so you can assume your assume the questions similar to your graded assignments and this practice assignments. Yeah. Input size is 10,000. Okay, so it isn't 10,000. So if we are giving some questions in the exam, we also know that what are the constraint you have. You have 3 hours. You have how many questions you have in the 3 hours duration. So any questions will not be this type of lengthy questions will not be there. There you have to spend a lot of time. Okay, so papers is this question paper is also decided in that manner, so you can complete the paper in 3 hours. Okay, here these are the practice assignments. So basically, you have enough time. You can run the code. You can just test. You can write the code for that. But in exam, you cannot do anything. So the question paper is also designed in that manner. Okay. जैसे कुछ assignment में error थी इस exam error free. Yeah, definitely the exam will be the error free. Okay, so professor have designed the paper and he reviewed everything. Okay, so you can assume that questions will be definitely error free. Okay, and we can close the session. Thank you, everyone. Best of luck. All the best.
Good luck, everyone. Thanks. Bye-bye.